Hello, my name is Jamil Siddiqui, and welcome back to I'm Not Afraid of the Exam's Afraid of Me. We're going to be looking at how we handle piecewise functions and limit problems on the AP Calculus exam. From the problem on September 12th, you may remember we were given a piecewise function and we were asked to find the limit as x approaches 4 of f of x. In order to handle this, we're going to have to go back and review what it means to be a limit and what it means to be a piecewise function. So without any further ado, let's take a look at those two things. Starting with limit. You may remember from our last time we talked about what the definition of a limit was. We said that a limit would exist if the limit of f of x as x approached a from the left equals the limit of f of x as x approaches a from the right. Now you may remember the whole idea of a limit was to guess what the output was going to be without actually getting to that point. We wanted to sneak up on our input, and we wanted to do it so that we came from both directions. If coming from the left and coming from the right, those two values agreed, we knew we'd be allowed to talk about the overall limit. This idea is imperative whenever we're talking about piecewise functions. I've looked at a lot of the AP exam problems from the last 50 years, and every time they're asking us to take the limit of a piecewise function, we've got to think about what's happening as we approach from the left and as we approach from the right. The next thing we really need to know about is our friend the piecewise function. Now this is a lot scarier than it looks for most math students. All we've got to do is understand the notation and we'll be able to take this problem down. In this particular piecewise function, we're given that f of x is equal to 3x minus 2 when x is less than 4, and f of x is going to be equal to x squared minus 6 when x is greater than 4. The idea of a piecewise function is that we want to use two different rules depending on what the input is. So for this example, we're told that anytime we want to plug in anything less than 4, we should use 3x minus 2. Okay? Less than 4, use the expression 3x minus 2. If we're using an input greater than 4 or equal to 4, we want to use the expression x squared minus 6. A really nice way to visualize this without spending too much time on it is to actually just draw a number line. If we think of this as the x-axis, and we know that 4 is what I'm going to call the crossover point. The point where we stop using one expression and we start using the other expression. If we know that, then what we can do is we can label the left side of this 3x minus 2, and that will represent that all the inputs less than 4 are going to be used with 3x minus 2. And we'll label the right side x squared minus 6, denoting that all inputs greater than 4 will use x squared minus 6. Now, we're told that when we're equal to 4, we should use x squared minus 6, but I gotta be honest with you, that's the least of our concerns when we're taking a limit. Remember, the limit's not concerned with the f of 4 value in this case. We're concerned with what's happening as we approach 4 from the left and from the right, and we want those two things to agree. So, in order for us to compute this limit, and keep in mind, this is going to be true not just for today's problem, for every limit problem you ever do with a piecewise function, you're going to want to look at what happens when we approach our values from the left and from the right. So, to start earning points on the AP exam, you're going to want to take this general idea and you're going to want to relate it to our specific function. We've got an a value of 4. I can almost guarantee you that every time you're doing a limit with a piecewise function, the a value is going to be one of these crossover points, okay? So in this one, we've got one crossover point. It's no surprise we're using that as the limit input that we're approaching. So let's set it up. Instead of a, we're going to use 4. We're going to take it from the left. We're going to take that limit as x approaches 4 from the right. And now we have to be super careful about what expression we use, because this is what they're testing us on. Are we going to know to come from the left and the right? We could use the general f of x, but that's not going to demonstrate our knowledge. So what we want to do is we want to say, what is the expression that we're actually using on the left side of 4? Well, this is where our handy dandy number line comes in. We're showing that that is going to be 3x minus 2. So we'll put in 3x minus 2 for that expression. And then coming from the right of 4, that's coming this way, we're going to be using x squared minus 6 for our expression. Once you've got these two one-side limits set up, it's now your job to compute these. So we're going to compute these limits trying by direct substitution at first. When we substitute in the 4 for our 3x minus 2, we end up with an output of 10. And when we substitute the 4 for our x squared minus 6, again, we end up with an output of 10. According to our definition of the limit, That says that our overall limit exists. Remember, the whole idea behind the limit is showing that you can come from the left, come from the right, and agree. We don't care about the actual output. You'll notice nowhere in our work are we addressing what's actually happening at 4. We're never saying find the value of f of 4. We're only approaching from the left and the right. Once we've been able to determine that the left and the right side are the same, we now know that our overall limit will share that value. So in this example, our final answer is going to be the limit of f of x as x approaches 4 is going to be 10. Notice I have to go back to the f of x notation because there's two different expressions, coming to 4 from the left and coming 4 from the right. I can't do both of them at the same time. By writing f of x, we're taking that into consideration. So what is it that you need to know for the AP exam? The chances of you seeing the problem I just showed you are slim to none. But the idea of seeing a piecewise function is pretty much a guarantee on the AP exam. We've got 3 topics, one that we've already discussed called limits, 2 more that are coming, continuity and differentiability. In each of these 3 topics, we're going to see piecewise functions. And when we see the piecewise functions, I can promise you the idea is that we're going to have to come from the left of the crossover point and from the right of the crossover point. Let's just discuss one more piecewise function very quickly. In this example, unlike the first one, we actually have 3 pieces. We're breaking up our number line into 3 different regions. So we're being told that the first cutoff point, or the first crossover point, is going to be -1. We see that right here. And the second one's going to be 5. According to this piecewise function, when we are to the left of -1, x squared will be our expression. When we are in between -1 and 5, we're going to be using x plus 4. And then in the final expression, when we're greater than 5, we'll be using sine x. If this problem were going to be on an AP exam, we would be asked to find the limit as x approaches either -1 or +5. Okay? Let's say that they asked us for the limit as x approaches -1. Remember what that means, okay? We've got to take the limit as x approaches -1 from the left, and we've got to take the limit as x approaches -1 from the right. Now, coming from the left, that's pretty straightforward. We've got our number line. Coming from the left side, we're using x squared. So this is going to be the expression that we'll be using in our limit. Now, as we come from the right, you may have some concerns because we're actually going to traverse past sine x and x plus 4. But this is where you have to remember. We're saying to the right of -1. So we're trying to get as close to -1 as possible. That means sine x is not going to be in play. Sine x can't get close to -1. It stops at 5. So the correct function that we're going to be using coming from the right-hand side of -1 is going to be x plus 4 in this case. So those would be to the 2 expressions that we would use when we're taking the limit as we approach -1. Just to finish this off very quickly, the answer for the limit as we approach -1 from the left, that's going to be -1 squared, that's going to be 1. When we approach -1 from the right, we're going to get -1 plus 4, that's going to be 3. These 2 limits are not equal, and anytime the left and the right don't agree, we can say our overall limit is undefined. If we looked at this problem again, but this time we took the limit as x approaches 5, we again would set it up coming from the left and the right, but this time we would have to be really careful about which expressions we're using. As we approach 5 from the left, that means coming in this direction, but just as before, you have to remember we're trying to get to the 5. So when we say approaching 5 from the left, we mean just to the left of 5. That means the x squared is not going to be relevant, and we're really going to be using the x plus 4 coming from the left-hand side. So that would get put into this expression right here. And now we'd have to approach coming from the right. This time it would be sine. As we take this limit, what we find out is the limit from the left side of 5 of x plus 4 gets us a value of 9. Now this other one might throw you for a loop just for a second because we're going to use the sine function, and what we're going to find out is we're going to get the sine of 5. Now you may not be comfortable with the sine of 5, but what you have to understand is the sine of 5 is a number. And more importantly, because we took trigonometry, we know that the sine is always trapped between the output values of -1 and 1. We can never get higher than 1, never drop below -1 for sine x. So if I ask, is sine 5 equal to 9, even though you might not be super comfortable with the sine of 5, you know that it's less than 9 because it never gets greater than 1. So in this case, again, the left-hand limit and the right-hand limit don't agree, so we can say the overall limit is undefined. If you found today's video helpful, make sure you follow us on Twitter and you like us on YouTube and subscribe to our channel to get the problems that we do each and every week. And remember, I'm not afraid of the exam's afraid of me.